Good morning. This is Professor Grenfell's Math 12 Statistics class. We are doing Chapter 10, Section 1 still. I am Chapter 10, Section 1. I don't know where that guy came from, but we're going to be doing another example today, 10-6, calculating the correlation coefficient. That's what the PPMC is. And yes, just because Chapter 10 has been hanging on for so long, just the first section has been taking a little while. Let's just do a quick recap. So the first was the notion of scatter plot. And so here, remember, we just would plot, we would create a point on the graph, a dot, if you will, plot it, okay, for each of the ordered pairs of data. Remember, we have pairs of data, X's and Y's that go together. So each one of these X values, that is X, and each one of these Y values, there it is, line it up, say that is Y, determines one unique point in the graph, like such, okay? So this point right here would be the X comma Y. And so after we do that, if we notice that there is any potential kind of correlation between these, then that's what we look at next. We actually will think about the correlation between X and Y and determine whether it is linear, and then we'll calculate it and test it. So the notion of correlation, remember, is if the X determines the Y value, and if so, does it do it in a way that's useful, that helps us predict, if we give it a certain X value, what will the Y value come out as? So the first thing that we do to kind of look at this is we go ahead and we take a look at our scatter plot, right? So look at the graph of this data, and I drew this yellow line in here, but I don't know if that actually really fits this data very well. I mean, it seems like there's a line or there's a line. It seems like the data is sort of all clustered together right there, but it doesn't have any kind of trend that suggests, if you give it an X, it'll give you a predictable Y value. So not seeing that, and you know what? If you don't see this, if you look at it and there does not appear to be any linear correlation, then actually after that, we don't even proceed any further. We would say, well, look, there's no bother even trying to calculate the correlation coefficient, because it's going to be so close to zero as to be insignificant. If it actually looks like there is a linear relationship between the X values and Y values, so just to kind of give you an idea of what a linear relationship might be, these 3 points aren't very noticeable, but something like this, if the data is kind of appears to be pretty centralized or pretty centered around a straight line, this yellow line kind of fits the blue points in this giant mess over here. So if it looks like there is a linear relationship, it looks like they are correlated, the X values and Y values, then we'll go ahead and calculate the correlation coefficient. So remember, that one is what we call the Pearson's product moment correlation coefficient, or the PPMC for short. So that's what example we're going to perform today. We're going to calculate the correlation coefficient, also known as the PPMC, but why don't we just call it R? Let's shorter than anything else. All right, so we're going to go ahead and calculate the correlation coefficient in this example for example 10-6. And just to give you a brief look ahead, after we do all of this, we look at obtain, we plot the data for our scatter plot. Lost my train of thought there. If it looks like there's a linear relationship, we'll proceed on to calculate the correlation coefficient. We'll perform this kind of tedious calculation to obtain a numerical value for the correlation coefficient, R. Okay, and then after that, so remember we do, if we have a sample, we do an exact calculation, but for the population, we never have that, all of that information available to us. We can't get all of the data within the population. And so what we always ultimately have to do is we have to perform a hypothesis test. So here we're going to be testing the significance of R and making a hypothesis about the population correlation coefficient, also known as rho. So that is, well, we're going to do step 2 out of those 3 steps. All right. As we had mentioned earlier, this is example 10-6. This is coming off of page 556. And here we're talking about the number of teachers and pupils per teacher to see if these two variables, data points are correlated to one another. So it says compute the value of the linear correlation coefficient for the data given in example 10-3 for the number of teachers in thousands and the number of pupils per teacher. So remember, the first thing that we would do is we would go ahead and create a scatter plot. And that is exactly what we did in example 10-3. So go back and look at the previous video for example 10-3. And then to calculate R, here's what we have to do. We're going to go ahead and just make a list of the various different data sources, let's say the sample items, and then, well, in this case, it's the different school districts. And then right here, we've got all of our X values, all of our Y values. These are already listed for us, probably, I'm guessing. We might want to recopy this list. And so for this particular example, let me go back and see what these were. Okay, so the X values were the number of teachers measured in thousands. And then the Y value, those were the pupils per teacher. So I'll just call that the PPT. Then what we're going to do after that is we're going to create another column, one for X times Y, another one after that for X squared, and then yet another column after that for Y squared. So remember how this works. We're going to go whatever the X value is, whatever the Y value is, within the same row, we're just going to multiply those together. I'm just going to go right there. Okay. We're going to look at the X value by itself, put a little box around it. Okay. And we're going to go ahead and square it and put it in here. And then same thing, the Y value, we're going to look at it and square it and write it down in this column. So we're going to proceed on this whole list of data that corresponds to district by district, school district by school district here. We're going to fill in all of the X times Y, all of the X squared, and all of the Y squared. So that after we do that, we can sum them all up. So here we're going to need the sum of X, the sum of Y, the sum of X times Y, of course, the sum of X squared, and the sum of Y squared. And to just reiterate this, remember that here you're adding up all of the x values, here you're adding up all of the y values, but the other values over here, the sum of x times y, the sum of x squared, and the sum of y squared, we do not use these values, these sums at all. We cannot use these in order to get these ones over here. We can't just take, for instance, we can't just take that and square it and say it's the same thing as that. No, remember we have to do this procedure where we get each of these individual values line by line, row by row, and then finally add them all up. So let's go ahead and do that. So of course, I did this the quick way. So I wanted this to be a quick example, and I did it with the spreadsheet. So I'm just going to write in these values. And I hope I'm able to create my screencast to show you how I do this in the spreadsheet so that you can utilize this as well. Yeah, so there those are. The sum of x is 151. The sum of the y values adds up to 133.9, and so on and so forth across the board. So then the rest of the by hand calculation is we have the formula for R. There it is, right there, that whole thing. And oh, yeah, I forgot. We have to remind ourselves here, N is equal to 10. And that's one thing that I might have overlooked if I had just copied these down and not looked at my original data again. Remember, okay, there are 10 values there. So go ahead and substitute in all of these values here, including n equals 10, into this formula. We'll calculate together. So there it is. We plug everything in just like that. And then carefully, we go ahead and instruct our calculator to perform the rest of that. So make sure you direct it specifically the way that you would have to do that. All right. And we get 0.442 after rounding. Oh, and as hopefully I'll be able to show you in the video where I demonstrate using a spreadsheet to help with these calculations and at least keep track of all of the numbers, which if you wanted to give me a screenshot of all of that, all of your work, and show me, include the formula bar so I can read it and make sure it's correct, yeah, for sure, do that. And then the nice thing about Sheets and Excel and what's the one for Mac? Numbers, I think. They don't even have to be a nice, like a full stat engine. They have a lot of statistical functions built in. So for example, here I typed in Pearson, and then I highlighted all of the all of the Y data first, and then all of the X data, because that is in Sheets how we are supposed to plug that in. And sure enough, I got the same thing as I did here, the exact same calculation. So there is that example, and then we'll move on now. We'll do that third part of it that I mentioned. We'll do the testing next.